continue problem 3. In the previous portion, we learned how to draw the PDM network for that problem 3 and complete the early start, early finish using back forward and late start and late finish using backward. And now we try to complete this problem to determine the total float, free float, and the critical path. And just go back to review the box, and you can see total float that show in the middle left, and then the free float show in the middle right, two red box that you have in there. So before we get into that problem, let's make how to determine the total float for total float. And total float, that is for TF, and TF is equal to, for the total float of an activity, it equal to the late start of that activity minus the early start of that activity, or it can be equal to the late finish of that activity minus early finish of that activity. And when TF equal to 0, then that activity is critical activity. So let's apply to here that to fill out the middle left box. So equal to either late start minus early start or late finish minus early finish. So for A, as you can see, 0 minus 0 or 2 minus 2, so it will be 0. B, 2 minus 2 or A minus 8, so it will be 0. A minus 2 or 11 minus 5, so it will be 6. D, 10 minus 8 or 11 minus 9, it will be 2. If E, A minus 8 or 14 minus 14, 0. F, 11 minus 9 or 14 minus 12, it equal 2. G, 14 minus 14 or 16 minus 16, 0. So that you have total float. And critical activity go to total float equal to 0. So in here you see A is critical activity, B critical activity, E critical activity, and G is critical activity. And same as problem 1 that we just did. Now we go back to determine the free float. Free float, and that FF. And what is that here? FF of the predecessor equal to minimum of the early start of the successor minus early finish of that activities. So with that one, and then we also have it always the total float always greater than or equal to free float. And if you remember what is the total float, the amount of time that activity can be delayed without delay in the project duration. Free float, the amount of time that activity can be delayed without delay in the early start of the successor. So with that one here, how can we find out minimum of early, and when no lead lag, we can say that in no lead lag. We can do that in the next lesson when no lead lag. So minimum of early start of the successor minus early finish of that activity you want to find out free float. So let's see here. For A, we want to find out the middle right box free float. It equal to the minimum of the early start of the successor. Two successor for A is C and B. So minimum of the early start of C is 2. Early start of B is 2. Minimum of 2 and 2 equal to 2. Minus the early finish of that activity A. Early finish of activity A is 2. So 2 minus 2, and you can see, equal to 0. B. Activity B. You have the minimum of the early start of activity D and E, because that is successor. D, E, 8, 8, so minimum 8. Early finish of activity B is 8. 8 minus 8 equal to 0. In other words, even you don't do it, you have a trick here. Total float greater than or equal to free float. And it's all about time. Then it cannot be negative. It's 0 or more. So whatever total 0, free float will be 0. So you do the same process, but you can close your eyes, fill out the free float for E equals 0, because free float cannot be greater than total float. So when total float 0, free float equals 0. G, close your eyes, put free float of G equals 0. So we only need to determine the C, D, and F, basically. Now for C. C, what can we do? How many successor for C? It's only one, that is F. That is F is the successor. Everyone see that there? And for that successor, the early start of that successor is 9, minus the early finish of C is 5. So 9 minus 5 equal to 4. So you have free float of activity C is 4. D. There only one successor for D is F, and it's 9. Early start of activity F is 9. Minus the early finish of activity D is 9, so you also have 0. Now F. You have one successor for F is G, and the early start of that successor is 14. The early finish of activity F is 12. So 14 minus 12 equal to 2. That is free float. So we can be able to find out fill all the information. Total float, free float, early start, and early finish. And now we want to be able to find out the critical activities. So that critical activity, as you can see here, go through A. So we can have that A through B. Then B go to E, and you can see that is the free float equals 0. And E go through G, so that you have the critical path. So from that one, you can be able to determine that is the project duration. Project duration 16 days, and then critical path, and that is A, B, E, G, and that is same as the problem 1 that you learned in there. Now I want to go further to explain what is the total float and free float. Total float is the amount of time that activity can be delayed without delaying the project. So what does that mean? B, total float is 0. A, total float 0. It means that if you delay 1 day, you delay that project 1 day. So from 16 to 17 days. D, you have total float is 2 days. Total float is 2 days. It means that you can delay the 2 days without delaying the project 16 days. That is the total float is all about. Now, free float, the amount of time that activity can be delayed without delaying the early start of the successor. Let's go to D here. Total float 2, but free float is 0. The successor of D, as you can see here, is F. F follow D, right? Successor is F. So you delay 2 days for activity D, the project still 16 days. But if you delay 2 days, because the free float of activity D is 0, you delay the early start of activity F from day 9 to day 11. You push activity F back 2 days. But the overall, you will not delay the project duration. So that is free float. So why free float also important? Just like D is one trade, F is another people doing it. So if you push back other people, they already mobilize the work, and then you delay, you will delay early start of the other activity that is on standby. It may have the economic loss for that trade. So that's why the free float also important. Total float for the whole duration. Free float is about how much you can be able to delay without delaying the early start of the successor, as you can see in example that I show you for D in these scenarios.